In this entire lecture, we are going to study about the algebraic identities, how to apply them while solving problems. Now there are two questions. First of all, what are identities? And second is, why do we need to study about them? So, what we can say is, identities are the results that are true for all the values of variable occurring in it. So basically, identities are results, and these results are true for all the values of variable occurring in any identity. Also, we find the application of identities in simplifying, evaluating, and factorizing algebraic expressions. So this gives answer to both our doubts. First of all, what are identities? Identities are simply the results, and these results are true for all the values of variable occurring in an identity. Also, for the second part, which is what is the application of these identities, we can say that these find application in simplifying, evaluating, and factorizing algebraic expressions. So from now, we are going to study about some of the very important identities and how to actually apply them while solving problems. So the first identity is a plus b whole square is equal to a square plus b square plus 2ab. So once again, a plus b whole square is equal to a square plus b square plus 2ab. Now, let's see how this identity comes. Let us look at the LHS. LHS is a plus b whole square. So now a plus b whole square could be written as a plus b into a plus b. So now when we multiply both these terms, what we get is a square plus ab plus b square. ab and ab gives 2ab, and thus the answer is a square plus 2ab plus b square, and which is actually the RHS. So a plus b whole square is equal to a square plus b square plus 2ab. Now this identity is true for all the values of a and b. So now let's see how to actually apply this identity. Find the value of 103 into 103. So we have to find the value of 103 into 103. Now using a calculator or a piece of paper and pen, you can calculate the value of 103 into 103. But we are going to solve this problem using the identity which we have just studied. How? Let's try to see that. Given to us as 103 into 103. Now this could be written as square of 103. Now 103 could be further written as 100 plus 3. So 103 square would be equal to 100 plus 3 whole square. Now this is exactly the same as a plus b whole square, where a is equal to 100 and b is equal to 3. So using the identity a plus b whole square equal to a square plus b square plus 2ab, we can say that 100 plus 3 whole square is equal to 100 square plus 3 square plus 2 into 100 into 3. This gives 10,000, this gives 9, and this gives 600. When we add them, we get the answer as 10609. So 103 square is equal to 10609. Thus using the identity, we have very easily calculated the value of 103 whole square. Let's try to solve one more example. If the value of 3x plus 4y is equal to 10 and the value of 2xy is equal to 4, then find the value of 9x square plus 16y square. So in this problem, we have been given that 3x plus 4y is equal to 10 and the value of 2x into y is equal to 4. And we have to find out the value of 9x square plus 16y square. Now using both these equations, we can find out the value of x and y and then substitute that value in this expression to get the final value of this expression. But here we are going to see how the identity helps us to very easily calculate the value of this expression. So given to us as 3x plus 4y equal to 10. Let us say that this is equation number 1 and the second equation is 2xy equal to 4. So these are the two equations that have been given to us. Now in the next step, what to do is squaring both sides of equation 1. So we square both sides of equation 1 and thus what we get is 3x plus 4y whole square equal to 10 square. Now this could be further written as 9x square plus 16y square plus 24xy. This we get from a plus b whole square equal to a square plus b square plus 2ab. Therefore, the value of 9x square plus 16y square plus 24xy is equal to 100. Now, this could be further written as 9x square plus 16y square plus 12 into 2xy. Now we know the value of 2xy equal to 4. So when we substitute this value over here, we get 9x square plus 16y square plus 12 into 4 equal to 100. And thus we get the final value of 9x square plus 16y square equal to 52. Thus, using the simple identity, which is a plus b whole square equal to a square plus b square plus 2ab, we have obtained this result. Now let's study the next identity, which says that a minus b whole square is equal to a square plus b square minus 2ab. The first identity was about a plus b whole square. Now let's study what happens when there is a minus b whole square. So a minus b whole square is equal to a square plus b square minus 2ab. So how do we come at this result? Let us look at the LHS, which is a minus b whole square. Now a minus b whole square could be written as a minus b into a minus b. When we multiply both these terms, we get a square minus ab plus b square. Now minus ab and minus ab gives minus 2ab, and thus we get a minus b whole square equal to a square minus 2ab plus b square. So a minus b whole square is equal to a square plus b square minus 2ab. So based on this identity, let's try to solve an example. Find the value of 999 whole square. So we have to calculate the value of 999 to the power of 2. So we are simply going to use the identity a minus b whole square equal to a square plus b square minus 2ab to find the value of 999 to the power of 2. But how? Let's see that. We can always write 999 as equal to 1000 minus 1. Therefore, the square of this number would be equal to the square of 1000 minus 1. Now here we see that 1000 is nothing but a and 1 is nothing but b. So this simply becomes a minus b whole square. Now a minus b whole square is equal to a square plus b square minus 2ab, and thus we can write 1000 minus 1 whole square equal to 1000 square plus 1 square minus 2 into 1000 into 1. This gives this value, this gives 1, this gives 2000, and when we add them, we get the answer as 998001. So the value of 999 whole square is equal to 998001, which is 9,98,001. Let's try to see one more example. If the value of y square plus 1 by y square is equal to 66, find the value of y minus 1 by y. So in this problem, we have been given that the value of y square plus 1 by y square is equal to 66, and we have to find out the value of y minus 1 by y. So now given to us is y square plus 1 by y square is equal to 66. Now we can write y minus 1 by y whole square equal to y square plus 1 by y square minus 2 into 1 by y. Y and 1 by y gets cancelled, and what we get is y square plus 1 by y square minus 2. Therefore, the value of y minus 1 by y whole square is equal to y square plus 1 by y square minus 2. Now we know the value of y square plus 1 by y square, which is equal to 66. Therefore, we can write y minus 1 by y whole square equal to 66 minus 2. Now 66 minus 2 is nothing but equal to 64. And if we take out the square root on both sides, we get the answer as y minus 1 by y is equal to plus minus under root of 64. Now this is equal to plus minus 8. Thus the value of y minus 1 by y is equal to plus minus 8. So simply using the identity, we have solved this problem. Now let's look at identity number 3. This identity says that a plus b into a minus b is equal to a square minus b square. So this identity simply says that the product of the sum of two numbers and the product of difference of two numbers is equal to the square of first number minus the square of second number. So again, let's look at the proof of this. Let's look at the LHS. LHS is equal to a plus b into a minus b. Now when we multiply both these terms, we get the answer as a square minus ab plus ab minus b square. Your minus AB and plus AB gets cancelled, and what we get is A square minus B square. Thus we have proved this identity, which is A plus B into A minus B is equal to A square minus B square. So again, let's try to solve an example. Evaluate 103 into 107. So in this problem, we have to find the value of 103 into 107. So again, in this problem, we are going to use the identity which we have just studied. So we have to find the value of 103 into 107. Now 103 could be written as 105 minus 2, and also 107 could be written as 105 plus 2. Now 103 into 107 could be written as 105 minus 2 into 105 plus 2. Now this is similar to A minus B into A plus B, where the result comes out to be equal to A square minus B square, and thus this would be equal to 105 whole square minus 2 square. Now 105 whole square is nothing but 11025, and 2 square is 4. Therefore 11025 minus 4 is equal to 11021, and thus we get the value of 103 into 107 as equal to 11021. Let's try to solve one more example. Simplify z minus 1 into z plus 1 into z square plus 1 into z to the power of 4 plus 1. So in this problem, we have to simplify this very expression, where the expression is z minus 1 into z plus 1 into z square plus 1 into z to the power of 4 plus 1. So the given expression is z minus 1 into z plus 1 into z square plus 1 into z to the power of 4 plus 1. Now what we do is we combine these two terms, z minus 1 and z plus 1. We know that a minus b into a plus b is equal to a square minus b square. This is similar to z minus 1 into z plus 1, where z is a and 1 is b. So when we combine them, what we get is z square minus 1. We keep these terms as it is. So z square minus 1 into z square plus 1 into z to the power of 4 plus 1. Now again, in the next step, what we do is we combine these two terms, z square minus 1 and z square plus 1. Again, we are going to use the same identity, and what we get is z to the power of 4 minus 1 into z to the power of 4 plus 1. So when we combine these two terms, we get the answer as z to the power of 4 minus 1, and we keep this as it is. Now again, in the next step, we combine these two terms, and using the same identity, what we get is z to the power of 8 minus 1. So this very long expression is actually equal to z to the power of 8 minus 1. So we have simply simplified this expression to a simple form just using the identity a minus b into a plus b is equal to a square minus b square.